Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on IGBT. So now here first I will explain basics of IGBT. Next is the symbol of IGBT, the difference between power MOSFET and IGBT, structure of IGBT, working of IGBT, transfer and output characteristics of IGBT, switching characteristics of IGBT, advantages of IGBT, disadvantages of IGBT, and next last one, applications of IGBT. So now here these are the basics. First basic, so now the full name is here IGBT, insulated gate bipolar transistor. So now here it is combined with both power BJT and power MOSFET, the combination of power MOSFET and power BJT. So now here combination of power BJT means MOSFET input characteristics and power BJT output characteristics. It has MOSFET input characteristics and it has power BJT output characteristics. And next, input characteristics. What are the most important advantage in power MOSFET is, so power MOSFET having high input impedance, that input characteristics having that IGBT. And next, the important thing in the power BJT output, main important thing is low on state voltage drop. This is output characteristics. Now this is in power BJT. Power BJT has low on state drop like BJT, power BJT. And next, another name for this IGBT, MOS IGT and COM FET and GEM FET and IGT. So these are another names. And next, it is a 3-terminal device. So in the BJT we have collector, emitter and base, and here drain, source, gate. But here in the IGBT, same one gate, input side gate and output side, input side of power MOSFET, that is gate, and output side of power BJT, collector and now this is G, collector and emitter. So now here this is the symbol. And next, here it is a fully controlled device, on state and off state. It is in our hand. We can control this on turn on and turn off switch, IGBT switch without using any external, any commutating device. So now here it is a unidirectional device. So now here its the direction is only from collector to the emitter. So now here another basic thing is it is a voltage control device. So its output current IC and output voltage VCE depending on the VGE only. So that is gate collector, gate emitter voltage. It's depending on voltage only, output voltage and output current. Because of that reason, this IGBT is known as a voltage control device. Power MOSFET is also voltage control device, but power BJT is the current control device. It is a minority carrier device. And next, non-linear device. Output voltage current characteristics are non-linear, because not a straight line, not passing through the origin. So this device is also known as a non-linear device. It is an active device. So now here it is having low input current. So it is having high input impedance means low input current, and it is free from secondary breakdown. There is no secondary breakdown because it is having flat temperature coefficient. Now only secondary breakdown voltage concept is in power BJT only. So now the last one, it is having flat temperature coefficient. Power BJT having negative temperature coefficient, power MOSFET having positive temperature coefficient, but here in case of IGBT it is having flat temperature coefficient. So these are some basic points. These things foremost, these things you need to remember. Now the symbol of power IGBT. So this is the symbol. It is having three terminals. So emitter, collector, and gate. So like in the IGBT symbol, this is IGBT. This is IGBT. So gate, gate, drain, source, and next this one is a collector, emitter, and base. But here input of power MOSFET and output of power BJT. So collector, emitter, and gate. So this is the structure of symbol of the IGBT. And now the real picture of IGBT, it looks like this. And next thing, here the structure of IGBT. Here in the same single silicon chip. So number of 1000 number of basic IGBT cells are connected here in this. So now here it is having one layer. First layer is a P plus layer. Only the difference between the power MOSFET and IGBT is this P plus layer. In case of power MOSFET there is a N plus layer, but here it is a P plus layer. Only that difference. And terminals, here the gate is same, but there is a source and here is a collector. Okay, so now here P plus layer, N minus layer is epitaxially grown on P plus layer, and P layer is a body layer is diffused into the N minus layer, and N plus layer is diffused into the P plus layer, and this is the SiO2 layer, and these are the metals. And here emitter is connected to this N plus, and collector is connected to the P plus, and E is connected to the emitter. Gate is connected to this SiO2 layer. So now here, so here if you see this one, this is SiO2 layer, this is body layer, P layer is a body layer, and drift layer is a N minus layer. This drift layer increases the the breakdown voltage of the IGBT. And next, this is the injecting layer. So now here this is the metal layer. So these are the different layers. So now this is about the structure of power IGBT. So now working of IGBT, how it will works. So first you connect this collector, voltage is positive and this is negative. So now here we have junctions. This is J1 junction, this is J2 junction. So this is J1 junction. So initially it is in forward bias and it is in reverse bias. It is in reverse bias condition. So now if it is when collector is positive with respect to this gate VCE, VCC, and next here there is no, because of this reverse bias condition, there is no current flows in this. So now here what will happen when it is connected plus and minus? So it is a SiO2 layer is a acts as a capacitor, and there is a channel will be induced, and so this will break down and current will flow. So here this electrons flows from in this direction, and here P layer injects holes into the in this direction. Here current, collector current and emitter current, because of electrons and holes, it is a minority carrier device. So now holes will enter into the N minus layer. There is a movement of holes. So because of holes there may be a current. Okay, same way here electrons enters into the emitter. Next after that N plus and induced channel of P and S N minus and A. Now this is in this way this IGBT conducts. And next, this is SiO2 layer, body layer, drift layer, injecting layer, metal layer, and current flows in this. So now here, what will happen? First here there is a parasitic. Then this is P, N, and P. One BJT. So this one, and this is RD is in the, it will offers one resistance, that is body resistance, that is in the N minus. Next, after that, here this is one thyristor. Thyristor is here. So here this is PNP and PNP, and this PNP, and this is here connected to this one. So now this is two transistor analogy. This is the same. If you draw this one, so this is same as that of this is transistor. So two transistor analogy. So if you connect two transistors, that is SCR, thyristor. So now here this is the IGBT. Here one concept is latch up concept. So that is here. So one thyristor. So in the thyristor, what will happen? So when collector current latch up. So latch up means when it is from in the thyristor, when it is from conducting from forward blocking mode to the forward conducting mode. Once it is latched into the forward conducting mode, so it is in on. So now when it will be turn off, so it will not turn off immediately. So when you give the external circuit, extra commutator circuit, then only it will be turn off. So here collector current increases when it is latched into the when it is IGBT latch up. So when collector current increases above the latching current, and then it will not turn. This is the latching. This is the latching up of IGBT. So it will not turn off, and the IGBT device may damage. Okay, no? So this is latching concepts. So now here input characteristics of power diode. So now here if you draw the not input characteristics, transfer characteristics of power diode. So IC and VG, IC and VG, IC and VG. So now here, so not this voltage is VG. So now here the graph is, it looks like this. So now here VG ET means that is threshold voltage. Up to this voltage it will not conduct. So here, because of internal capacitances, after that it will reach. The graph should be like this for transfer characteristics of IGBT. So now here output characteristics are drawn between IC and VCE when VGE is constant, and here if you VG is for this particular VGE is equal 0, is equal to 1, 2, 3, 4. VGS VG is greater, 5 is greater than VG4, VG is greater than VGE, 4 is greater than VGE, VG3 is greater than VGE, 2 is greater than VGE2. So now here the graph should be like this for output characteristics. So now here say switching characteristics. What about switching characteristics? Here switching characteristics are here first turn IGBT acts as a switch. So here turn on characteristics and turn off. Switch means turn on and turn off. So the turn off and turn off characteristics first. In the turn on, TDN and TR. So TDN means delay time, turn on delay time, and rise time. So here turn on delay time means here we have two words, output voltage and output current. Output voltage here during which the time during which here VCE falls from VCE to 0.9 VC. So now here this is VCE and falls from this is 0.9 VCE, 0.9 VCE. And otherwise we can determine in another way we can define this turn on delay time during which this ICE, this leakage current, this IC current actually, so that leakage current is ICE from ICE to 0.9. So ICE to 0.9 IC. So this period is known as a turn on delay time. So now here next term is the rise time from this 0.9 VCE to from the 0.9 VCE to 0.1 VC. So now here this point and this is 0.1 VCE, and next another definition is here from the IC rises 0.1 to this 0.1 to this is 0.1 sorry 0.1 to 0.9. So 0.1 to 0.9. So IC is known as a rise time. So now again this is turn on plus turn TDN plus TR equals to TON, and here thyristor conduction period. This is conduction period, and after that here turn off. You need to turn off this thyristor IGBT. So now this here we have three times here: turn off delay time, fall time T1 and fall time T2. So now here turn off delay time during which VG. So this VG falls from VGE to VGT. So now here to VGT. So now this VGT already gate emitter threshold voltage from VGE to VG, and next during which and IC falls from IC to 0.9. So now here it falls from this is IC and falls to this is 0.9 IC. And next another definition is here VC begins to rise. So here from here to B, this is delay time. This is delay time, turn off delay time, and first fall time is during which 0.92 here 0.92 0.2 IC, and next here this is 0.1 VC, VCS2 and 0.1 VCE. So now this time is fall time 1, and next fall time 2 is second fall time is from 0.22 and 0.1 IC, and next here to 0.1 VCE2 and next VCE. So that is fall time 2. So now fall time 2 plus fall time 1 plus turn off delay time is known as a turn off time, that is represented with TQ. TQ is always circuit turn off is always greater than turn off time of IGBT. So now here these are the advantages. What are the advantages here? It is voltage control device. It has very simple gate drive and less cost. On-state losses are reduced, and it can be operated at high switching than SCR, and gate has full control over the operation. It does not require any commutation circuit. Means it is a fully controlled device, and it has a flat temperature coefficient. It does not require any external circuit. It is a fully controlled device. It does not require any repeated 2 times. And next here it is free from secondary breakdown. What are the disadvantages? Here it suffers from static charge problem. It suffers from latching up problem. Once it is latch up and we cannot turn off easily, and it is costlier than BJT and MOSFET, and uh, high turn off time compared to the power MOSFET. And what are the applications here? Um, it is used in AC motor drives, inverters, DC to DC power supplies, chopper, UPS systems, uninterrupted power supplies, harmonic components, relays, and contactors. So now here, I hope all these concepts are clear to you. If you still have any doubts, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.